Everybody, this thing working? Yeah. So this is our team: Toba, myself, Zipo, and Alan Christoffels. Okay. Yeah. Shall we just wait a minute? The people are filtering in. There aren't as many people as there were before, because people have already started to leave. Okay. So yeah, hello from South Africa. We are from the South African National Bioinformatics Institute, and we are working currently on tuberculosis. But before we were doing that, we were working on a fish, the Asian sea bass, Toba and myself, and we were involved in the annotation of the genome of this fish. So then, of course, we had to face the problem: what are the options for storing annotation for a genome? So, well, you could just store everything as flat files and GFF3 files or something like that, but then it's rather difficult to search and link to other data. Other flat files, behind the scenes, JBrowse uses JSON for its storage, or Chado. It's a lot talked about in this field. But then we ended up rolling our own SKO Alchemy-based object model with a Postgres database, and it grew and grew and grew. And eventually we had 300,000 protein entries from sea bass and other fish, and it was getting rather slow. So maybe we should have just used Chado, except this is a sequence feature in Chado, let alone the rest of Chado, which are all these different modules. So the thing about genome annotation is that you start with it and then the needs grow, okay? And specifically, the relatedness of things grows. So it becomes harder and harder to craft efficient and intuitive queries, okay? And also, Chado is relational, but not object relational. So then we started looking into graph databases because one of our faculty members uses this for exploring disease genes. And in graph databases, every item, so what you would think of as a row in a relational database table, becomes a object, a node, okay, with all its attributes. And the relationships between nodes are explicitly there. It's not like you have to compute them with joins. Queries are expressed in a query language called Cypher. And yeah, so one of my colleagues has built something called the Borg out of graph databases, so he has some experience with them. And we are using the Neo4j Community Edition graph database. So this is what the Neo4j shell looks like, that we have entities, as I said. So if you can think of every entity there as being either one gene, or that in fact is genes, interprotomes, GoTerms, proteins, transcripts, all related to each other, okay? So the nodes and the edges. And every node has a bunch of attributes that you can't see on this diagram. So if you build an evolving model for genes and other genomic features, protein interactions, and so on and so forth, okay? Sorry, I think something, yeah. And then you interact with it. Neo4j is written in Java, and you interact with it via a RESTful API. There is a binary protocol coming soon. And we use an object graph mapper that maps classes to object labels, attributes to node attributes, and relationships to edges. And then we load it via the object graph mapper, something called a NeoModel. And then sometimes if we want to be doing things that are difficult to do via the Python object graph mapper, we just speak Cypher query language directly. And then we've created Zipo's created a NeoStore data type so that you can store your graphs within a Galaxy data type. So if you've got the background annotation, then that could be one data type, then you maybe add some more annotation, and then you get a second history item. So thereby, you're not messing with the database, you're just always seeing a newer version, you can always go back. So this is what Cypher looks like, okay? If you look at it, you see it's basically a bunch of terms in brackets connected with arrows. And the arrows happen to be going this way. What this does is to match a Go term, find the protein it's associated with, find the CDS that gets translated into that protein, find the transcript that is processed into the CDS, and find the gene which is transcribed into the transcript, okay? And then return the GoTerms ID and count the occurrences of the gene. So effectively, this will tell you how often a particular GoTerm exists in your annotation database. This is part of the code that I've got for my gene set enrichment analysis tool. And I mean, it runs pretty quickly. I mean, if you look at that in terms of SQL joins, it would be quite a few joins, but this, counting all the prevalence of all the GoTerms in the tuberculosis database takes under a second. And that's on a fairly modest machine. Okay, so just a few pros and cons. It's very intuitive to model this way. You basically say, you know how you model. You go to a whiteboard, you draw, I've got a this connected to a this. Then you go to Cypher, and there you make a this connected to a this. You know, it's very straightforward. And to extend the model, okay? And when I say extend the model, it's because there is actually no schema. So you're not locked into what was decided last week or last year. And the queries are pretty fast. Having said that, the graph database is not like some other NoSQL databases that allow sharding. You can't shard. It all runs within one server. Okay. Cons is there are no schema. Those of us coming from a relational database background, especially things like Postgres with relational integrity, like schemas. We like the safety it gives us. And in part, we can solve this through having versioning and building the graph in layers so that you can go back to a previous version. The Neo model object graph mapper is slow for bulk operations. Yeah, that's the last con. And of course, the other con is that there's all this work that's been done in Shader, and now we're kind of reinventing the wheel. But if somebody can show me how to use Shader easily and effectively, then maybe we wouldn't be doing this. So finally, my time is basically up. The actual database for tuberculosis is available on Figshare. For more on graph databases, see our GCC 2016 page, which is bit.ly/ctb-gcc16.
Thank you, Peter.